Hello guys and welcome, CPP Dev here. In this first video from the series I'm going to provide an overview over the concept of the containers. Please note that the information in this video and also in further videos from the series is based on multiple websites like cppreference.com or c++.com, the Mastering the C++17 STL book, which you can find in the description below, so don't forget to check it out, and also what is a container? A container is actually a holder object that stores a collection of other objects, the elements. They are implemented as class templates, which allows a great flexibility in the types supported as elements. The container manages the storage space for its elements and provides member functions to access them either directly or through iterators, which are actually reference objects with similar properties to pointers. The goal of the standard container classes is to provide access to a particular bunch of data objects while making sure that the ownership of these objects is always clear, namely a container always has ownership of its data elements. First, a little bit about the notion of ownership. When we say that object A owns object B, what we mean is that object A manages the lifetime of object B. That A controls the construction, copying, moving, and destruction of object B. The user of object A can and should forget about managing B, for example via explicit calls to delete B, fclose B, and so on. The simplest way for an object A to own an object B is for B to be a member variable of A. Another way is for A to hold the pointer to B with the appropriate code in the A destructor to clean up the resources associated with that pointer. The notion of ownership is tightly bound up with the C++ specific catchphrase resource allocation is initialization, which you will often see abbreviated as RAII. Now that we have this information about what is a container and what is the notion of ownership, let's take a look into a simple container example. Please note that this example is a bare minimum for a container and also it's not the best in terms of resources usage. The containers library provides three groups or classes of containers. There are the sequence containers, associative containers, and unordered associative containers, each of which is designed to support a different set of operations. The sequence containers are array, vector, deck, forward list, and list. The associative containers are set, map, multiset, and multimap. And the unordered associative containers are unordered set, unordered map, unordered multiset, and unordered multimap. There is also the group of the container adapters, which is formed by stack, queue, and priority queue. Most containers have at least several member functions in common and share functionalities. Which container is the best for the particular application depends not only on the offered functionality but also on its efficiency for different workloads. Since this video is only meant to provide you an overview about what is a container and which are the STL containers, I think we can stop here. I hope that you learned something new from this video, and if you did, don't forget to like it and share it to other people that you think might need it. Each of the container types will be covered in its own video in the future, so don't forget to subscribe to the channel so you don't miss anything. Thanks for watching, CPP Dev out.